Today we will study reliability analysis, which is a very important concept in medical research because before using any instrument, scale, or diagnostic method, we must know whether it gives consistent results. What is reliability? Reliability refers to how consistently a method measures something. If the same results can be consistently achieved by using the same method under the same circumstances, the measurement is considered reliable. Types of reliability. There are two core types of reliability, internal and external. Internal reliability, consistency within the instrument is itself. External reliability, consistency of results from one use of the test to another. Internal reliability, internal consistency, the individual items of a test. External reliability, test, retest reliability, inter-rater reliability, parallel forms of reliability. Test, retest, the same test over time, inter-rater, the same test conducted by different people, parallel forms, different version of a test which are designed to be equivalent. Common reliability statistics. Intraclass correlation coefficient. Bland-Altman analysis. Kappa Statistic. Kendall's coefficient. Different reliability methods are used depending on the type of data. Continuous data often uses ICC and Bland-Altman, while categorical data use Kappa. Bland-Altman analysis plot. Agreement between two quantitative measurements methods by examining mean difference and limits of agreement. Bland-Altman does not simply show correlation, it shows agreement by examining differences between two methods. The formula of difference is equal to method A minus method B and mean is equal to method A plus method B divided by 2. We calculate the differences between methods and plots against the average. For example, comparing glucose measured by laboratory machine and portable glucometer. Lab and glucometer readings are given. Find the mean and the difference between the lab and glucometer readings. Or draw Bland-Altman plot. Consider medical example comparing glucose measured by laboratory machine and portable glucometer. We have 5 patients reading, lab readings and glucometer readings. First we find the mean in SPSS and find the differences. For this we open our SPSS file. In variable view we create 3 variables: serial number, lab and glucometer, and in data view we enter our data. Or create the mean variables, we go to transform compute variable. In compute variable we name the target variable mean and move laboratory variable in numeric expression. Press the plus sign and move glucometer reading and press the divide button and divide by 2. Press OK button. Or create the difference variable, we again go to transform and compute variable. In compute variable window we name the target variable is difference and move lab variable in numeric expression. Press the minus sign and move portable glucometer reading in numeric expression and press OK button. Our mean and difference variable created in SPSS. Draw the Bland-Altman Plot, go to Graphs, Legacy Dialogs, and go to Scatter Dot. In Scatter Dot window, press Simple Scatter and press Define button. First, we move difference variable in y-axis and mean variable in x-axis and press OK button. In output window or viewer, scatter plot show SPSS show the is scatter plot. To draw the y-axis mean and 95% confidence interval lines, we first find the mean and 95% confidence interval. Go to Analyze, Descriptive Statistics and Explore and move difference variable independent list and press only statistics button and press OK. Here our mean is minus zero point 0.2 and confidence interval lower bound minus 2.744 and upper bound 2.344. Now we draw these lines, mean lines and 95% confidence interval lines. Double click the plot and go to the option for mean lines. Draw the mean lines. Press y-axis reference line button and give the mean values minus 0.20. Press apply button. Before draw the 95% confidence interval line, we close properties and double click the minus 2 and go to scale and uncheck the auto button and give custom value minus 3 and 3 because our value is greater than 95% confidence interval value is greater than minus 2 and 2. Press apply button and close these properties and again go to option button and y-axis reference line. Here we give the upper lower 95 confidence interval minus 2.744 minus 2.744. Press apply button and close this properties window and again for upper bound reference line y-axis reference line put the value 2.344 2.344 and press apply and close this button and cross the chart editor. Here show the Bland-Altman plot and then plot the mean difference, limits of agreement. If most patients lie within limits, agreements is acceptable. Bland-Altman advantages and limitations. Detect systematic bias. Show clinical agreement, visually widely accepted in medical journals. Limitation only for two methods. Please subscribe and like our channel and press bell icon for more videos.